Number 10, the kinetic energy in joules of an object with mass of 9 kilograms traveling at a speed of v meters per second is given by the function k, where k of v equals 9 halves v squared. Before I go any further, I'm going to write down everything that I know about this equation, this function. Okay, so k of v equals 9 halves v squared. So there's an object with a mass of 9 kilograms. Now it's tempting to think, since it's 9 kilograms and we have a 9 here, that 9 represents the mass, but we're not told that. We're not. So don't assume what's not told. What is told is that v, the speed, is v meters per second. Okay, so v here is my speed in meters per second. All right, that I am told. And I'm told that the kinetic energy is given by this function. Okay, so the function is giving me the amount of kinetic energy for this. So if I do this math over here on the right, I will get the kinetic energy. So that means my output is the kinetic energy, the output of that function, because that's all functions are, is input and output. The k of v, the f of x, all that is the output, saying like, okay, when I put whatever's in the parentheses through this equation, what do I get? In this case, I'm getting the kinetic energy. Okay, so which of the following is the best interpretation of, move up here, k of 34 equals 5,202. Now, anytime they say the best interpretation, I try to go through and come up with my own interpretation, and then I see which of the 4 options is closest. I generally do not start with the multiple choice. Some people prefer it that way. I don't. So I like to get my own idea, and then I find it's clearer and easier to pick out the right one, because often these are very similar. So I want to know what I'm looking for before I go looking. Okay, so k of 34. K of 34. What is in this parentheses? What is it up here? It is v. 34 is my v. And I'm told, what is v? V is the speed in meters per second. Okay, so again, up here, this function up here says, if I plug in a number for v, and v is my speed in meters per second, and I do the math, I'm going to get kinetic energy. All right, so with that in mind, I'm looking down at this new one that they've given us, k of 34. So I think this means that if my speed is 34 meters per second, so if my speed is 34 meters per second, then my joules would be equal to 5,202. That I would plug in 34 as my v, my meters per second, I would do the math, and I would get my joules. Okay, so speed 34 meters per second, joules 5,202. Let's look over here at our options. First one says the object traveling at 34 meters per second has a kinetic energy of 5,202 joules. That looks right off the bat like that's the one we want, but let's look at the others because it is the best interpretation. Sometimes they may be close. B, the object traveling at 340 meters per second has a kinetic energy of 5,202 joules. No, there's 340 is not the speed of this. It was 34. B is out. C, the object traveling at 5,202 meters per second has a kinetic energy of 34 joules. I see they're transposing them, and that's not what it said. It said V was the meters per second, and V is that 34. So no, C is not it. And finally, D, the object traveling at 23,409 meters per second has a kinetic energy of 34 joules. No. Confirmed A is our correct answer. It is A. Hey guys, just a quick heads up. I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.